Okay, hello everyone. This is Group 3. Our title is about the physics of gyroscopes and the application in navigation. Here's our table of the contents. The first part is the introduction. The gyroscope is an angular motion detection device made of a high-speed rotating shell. Gyroscope has become one of the most important branches in the development of dynamics. The most widely used field of gyroscopes is navigation. Based on interior and using the dynamic characteristics of the gyroscope to obtain our information, we can control the flight path, the ship stability, and so on. Finally, realize the role of navigation. For the history of the gyroscope, in 1832, Professor Walter of the University of Minnesota exhibited a rotoscope similar to the real gyroscope. After 20 years, the Foucault named and built the first gyroscope, and the development of electricity in the 19th century led to the electrorotor, which also led to the gyrocompass. And Elmer built the first automatic gyrocompass for aircraft and sold it first in the USA. During the World War II, people succeeded in putting aiming gyroscopes into aircraft and anti-aircraft gun sets. At the end of the 20th century, and the development of the microelectronics technology, the gyroscope structure became more complex. It in the real sense come into people's ordinary lives. Nowadays, the gyroscope has already become a necessary part that can be easily found in the near devices, such as the UAV, the vehicle, even our smartphone.
Hello everyone, my name is Du Ruoyu. I will introduce the principal part. As we all know, gyroscope is widely used in modern society. However, for the traditional mechanical gyroscope, it is an instrument to measure angular vector and maintain the orientation, which is based on the law of conservation of the angular momentum. A gyroscope always has one rotor and two or three gimbals. This is a gyroscope that consists of a spinning mass with a high angular vector that rotates about a fixed span axis. The rotor is mounted into three gimbals which can provide supports. Next, I want to introduce the two important characters of the gyroscope. The first is called rigidity. When the rotor of the gyroscope rotates with a high angular vector and the none of the outer moment applies to the gyroscope, the direction of the rotation axis of the gyroscope does not change and resist any force that changes the direction of the rotor. This character is called rigidity. The stability of the rigidity can be affected by these physical quantities. The first is the momentum on inertia. The larger the momentum on inertia of the rotor is, the better the stability is. The second is the angular vector. The higher the angular vector of the rotor is, the better the stability is. The second character is called the precession. When the rotor rotates with a high angular vector, if outer moment is applied to the outer gimbal axis, gyroscope will rotate to the inner gimbal axis. If outer moment is applied to the inner gimbal axis, the gyroscope will rotate to the outer gimbal axis. The direction of the angular vector is perpendicular to the direction of the outer moments. This character is called precession. There are three factors that can affect the precession. The first is outer force. The larger outer force is, the higher precession angular vector is. The second is moment of inertia. The larger moment of inertia is, the lower precession angular vector is. The last one is angular vector. Here the angular vector of the rotor is. Here position angular vector is. That's all. Thank you.
Here is the application part. So as just mentioned before, Foucault first proposed the definition, principle, and the application of gyroscope in 1852. Because of its physical properties, gyroscope was first proposed to use in navigation. And at the beginning of the 20th century, the invention of the practical gyrocompass marked the formation of the gyroscope technology and the beginning of its modern application. So we just know when a gyro is spinning at high speed, it can rotate about a fixed axis, but the fixed axis is easy to be destroyed and make the gyro center of gravity offset. So it will lead to the gyro can't accurately determine the orientation. Just as shown in this picture, we can see when a spinning gyro moves from point A to point B on the Earth, it can't continue to point due north if we look at it in space, and the mean axis will change. But on the other hand, we can imagine if this situation can be eliminated, then the gyro can point in one direction. If the direction is due north or south, a gyro compass may be used to indicate the direction. So the scientists attempt to apply an external torque, also known as the controlling torque, to control the direction of the gyro's main axis. For example, like this picture, we use liquid to apply a controlling torque that causes the gyro to always point due north as it rotates. And as this picture shows, the axis will point the due north as the gyro compass moves on the Earth. So this kind of gyro compass is called a liquid floating gyro compass. And in addition, the controlling torque can also be applied by hanging a heavy object or something. So in the modern, different companies have their different structure and the working principle of gyro compass. And there are three series in the world. They are Anseus, Spaley, and Amabron. So this picture shows the kind of Anseus gyro compass. So we can see nowadays the structure of gyro compass is complex and complete.
I will briefly introduce the rate gyroscope, modern gyroscopes, and gyroscope in navigation. The rate gyroscope uses the special properties, the fixed axis, and the positions to calculate the angular velocity in a certain direction. The rotation of the rate gyroscope around the axis will subject to elastic constraints. When the gyroscope torque is balanced by the elastic constraints, the output signal is proportional to the angular velocity. And next, modern gyroscopes. I will do a quick introduction of them. First, fiber optic gyroscope. By measure the phase shift of the two beams to rotate the sensitive carrier, the angular rate can be calculated. Now the fiber optic gyroscope have been widely used in the torpedoes, submarines, and spacecrafts. MEMS gyroscope. MEMS gyroscope is the integration of the mechanical elements, the micro sensors, signal processions, and the electrical sources of complete systems. Its accuracy is not good as the fiber optic gyroscope, and it needs the data of other sensors to release its functions, but the cost is quite low and can be mass produced. Next, the laser gyroscope. It uses the laser technology to measure the angular velocity, and the main advantage are the simple structure, good anti-vibration performance, and higher reliability. Finally, I will talk about the gyroscopes in navigation. And maybe you will ask that we can use the GPS to navigate. What can the gyroscopes do? Yes, the GPS can navigate in normal, but when the when the signal of the GPS is weak, the gyroscopes will show their abilities. When the GPS signal is not good, the gyroscope can continue to navigate according to the known direction and the speed, which is also the basic principle of the inertial navigation technology. What's more, the gyroscope can provide more sensitive and accurate direction speed than GPS. GPS cannot detect a change in your car's speed or direction immediately until you have traveled for a certain distance. In addition to the vehicles, the gyroscope can also used in the aircraft and missiles and the drones for navigation.
Except for the forward part application, there are still some defects happen during the gyroscope development, such as the gimbal lock. In the process of the initial navigation, there is an important part of the gyroscope, the gimbal. As shown in the figure, the gimbal needs at least 3 directions to maintain stability in the space: the right y-axis rotation, the blue x-axis rotation, and the green z-axis rotation. When the aircraft or the ship is raised 90 degrees, 2 of the 3 gimbal systems and their pivots are aligned in plane, and the following gimbal locking phenomenon may occur. At this time, the rotor and the rotating shaft will not be able to maintain balance. Eventually, the three-dimensional gimbal system lost a degree of freedom. And for this problem, we can overcome it by using the force gimbal. For this problem, the motor drives the force gimbal to ensure that the angle between the yaw and the roll axis are large enough. There are still some weak points need to be solved, like the gimbal lock, and that's the driving force for the continuous improvement of the gyroscope. And that's all for our presentation. Thanks.